Hello and welcome to this week's screencast. I'm going to walk through assignment 2 real quick and then we can jump right into decision structures, if statements, if you will. So for assignment 2, due Tuesday, published on D2L, we're building a loan calculator app. Right? It's a monthly loan calculator app. And there should be an Excel spreadsheet on D2L that shows you some sample data. You want to use this as the basis for testing your code, right? So for whatever code you write, if you plug in these values, you would want to be able to see this output on the screen in your ASP.NET Web App. So let's walk through what the user interface looks like. We're going to show some date in the app, so you know how to do that, probably on page load. You've got three different text boxes, and then you've got a drop-down list. So for a drop-down list, instead of doing something like something.text, control.text, the property that you'd be working with is .selectedValue. So you could probably plug in a drop-down control, add some sample data, and when you write your C# code, you'd look for drop-down loan period dot selected value to get the value that the user selected. Right, that's the only thing that's going to be different. You've got two buttons here. You've got a clear button. When you click on the clear button, the idea would be that you would clear the rest of these text boxes to reset them to zeros or blank, and then the results will be reset to zeros, right? And if you click on the calculate payments button, then it would take the input, all four inputs, not just three of them, all four inputs, and it would use it to calculate the monthly payments, and then you could derive the total cost of the loan. I give you the formula for calculating the monthly payments, right? So the formula for calculating monthly payments is going to be the loan amount, L, right, times the interest rate, R, but notice R is monthly interest rate. Typically when you're given interest rate, the sample data you might be playing with is going to be annualized, is that at the APR level, right? Annual percentage rate, right? You're going to want to, number one, convert this to a percentage value. If I type in 4, you can't type in 4% in your code. It's likely to fail because that's, try to convert that to a double, you're going to have problems. You're going to want the user to type in 4 in your scenario in this interest rate area. Notice I put the percentage here, and the percentage is not something you should be expecting a user to type in. If they type in, you have to do a lot of code error handling to support that, to avoid that. But you probably want to divide this by 100 to get the right value, and then you might potentially consider dividing by 12 to get the monthly equivalent of the annual APR, right? So that's a gotcha you want to be aware of. N is the number of payments. The number of payments is in periods. That also needs to be at the monthly level, right? So I would consider a user is selecting 30-year loan, 15-year loan, 5-year loan. It would be smart if you convert it down to months, as in multiply by 12 to get how many total months or periods are involved. What I would do is, if I have loan down payment, I would subtract the down payment from the original loan amount to get the actual amount of the loan that I have to pay. So if I would buy in a house for $750,000 and I put down $100,000, I'm only paying on the $650,000 that's left, right? So you have to do some calculation there. And then now your code output should be showing monthly payments of this amount if you plugged in the same kind of data scenarios, right? Obviously, you have a drop down, so you won't be typing in 60, you'd be selecting 30 years or 5 years or 15 years, and you would expect the calculation to work that way. Total cost of loan, pretty easy. it's practically B6, as which you can see is the length of the loan, right? Number of months um, equivalent times the monthly payments will give you the total cost of the loan. So there you go. Um, Otherwise, you've got the formula here. Um, Most important thing, please use your initials as a prefix for the control names instead of just TXT loan amount. You must use first name, last name, initials as the prefix of your controls. If you don't do that, I would assume you copied somebody else's work and you get 0. This is very important. Even if you do the work and you don't rename these, start by naming these correctly. Because if you go back and rename them after you've finished the code, you're going to have hell. It's going to be really painful. And it's meant to do that if you're copying somebody else's work. I expect you to struggle through this, right? The goal is to do this yourself so you'll be better prepared for the midterm exam. Once you're done, zip up your work, upload to assignment 2, Dropbox folder. Make sure you zip in the right folder. Some gotchas to think about. When you try to create this formula, please break this down. I'll create a variable for just L times R, the numerator. Calculate that separately. It'll make life easier to debug your code. Then I might calculate maybe 1 divided by 1 plus R as a separate variable. Create as many variables as you need to split up this very complex equation into smaller parts. If you try to write one line of code to do this, when you have errors, you're going to spend hours and hours and hours trying to troubleshoot it because you did not follow the right best practices for solving complex problems. When you have a complex problem, the goal is to split it up into smaller problems so you can solve those smaller problems and roll it up, right? So I would try to figure out what's L times R. Does it give me the right results? Perfect. What's 1 divided by 1 plus R? Does it give me what I need? Okay, now that's good. Then raise it to the power of n, right? Once I do that, I might do 1 minus this whole thing, right? And then perhaps divide the denominator over the numerator. So create as many variables as you need to split up the problem into very small, nice chunks. Don't write one line of code to do this whole thing. You're going to spend lots of hours painfully troubleshooting, right? But if you split it up into smaller problems, it'd be easier to troubleshoot your code and see where things are going wrong, if things are going wrong. All right, excellent. So if you decide to implement the power capability of it, then you would be interested in, so you want to use math.pow instead of doing something like something to the power of something, right? So math.pow would assume that we have the original value to the power of something. And I'll illustrate that briefly here. You want to make sure you've got the using system namespace up in your code before you use math.pow, because the math.pow function is only available if you reference that. So here's an example. So if I wanted to do something like had like a double of a variable named a, and it's equal to 5.0, and I had another double b, and it was equal to 6.0, and I wanted to use, maybe I created another double of c, and it was equal to math.power. You notice math.pow accepts doubles, right? So make sure you're plugging in doubles and not integers. Even though 5 is a whole number, I rewrote this as a double, right? So it would fit this. So then I can plug in a, b, right? And perhaps maybe I could even console.writeLine or console.write maybe c, right? So let's get rid of this hello world because we don't need that. So that's what I ended up getting. I'm not quite sure if that is right. maybe we could try this out. And we get 25, which is something I'm more comfortable with. So 5 to the power 2, which means 5 times 5, gives me the right result. So now you know math.power is working. So if you need to test your code, you could test it in Rex Tester initially, different parts. But this is a web app, so don't build this as a console app. It needs to be a web app, right? It's got a nice user interface. All right, so that's the assignment. Let's jump into the lecture slides. And we can do that here. So we talked about exception handling. Here's an example. Try to play with it in prepping for your midterm. All these practice exercises, you want to try to practice those. You want to build muscle memory, right? A lot of what you do in programming, muscle memory is going to be very critical to that, because sometimes your fingers would figure out how to write the code before your brain catches up to it, right? The more you practice, the better it's going to be. All right, so variables in calculations, we talked about this. We showed you some examples of how you would express a scenario where you're adding a value to the original value of some variable. So x is equal to x plus 2 could be expressed as x plus equals 2. I just wanted to show you some additional options where you can have something like minus equals, multiply equals, divide equals, right? That's also feasible. It's not just for plus equals, right? So that's what that slide is all about. If you're creating a variable that cannot be changed at runtime and is a constant, even though we probably would not use constants very often in this class, then you could put the keyword const in front of the data type, right? So that's the syntax. You're going to have to specify the keyword const in front of the data type, and then specify the name of the variable or constant, if you will, and then initialize it. Right? So that's the approach. For constant, an initial value is required, right? Let me bold that and green, make that green. That is absolutely required. So it's not an optional value. There's this other concept of class level variables. So far we've been talking about classes having methods, and we said an event handler is a method. So page load is a method. You could have a click event that's also a method. In some scenarios, when you anticipate that you might be creating potentially a variable that could be used across multiple methods, you would define that variable at the class level. So notice I created a constant, which is a type of variable, if you will, or container. I'm initializing the value to 9, and now I created another variable called second value, and that's initial value is 4, and then I'm dividing my value by second value. So this is outside of this method, but because it's defined globally at the class level, I can use it in any method. If I had a second method, I could even use the value of this guy, right? So this is useful if you need to use a specific variable across methods, right? So be aware of it. Control flow. So control flow is a way to make decisions in code. So if you recall what we did with activity diagrams, we had decision nodes that were this diamond shape, and they always have some type of input coming in, and potentially they might have a branch. If something is true, they would do something, or they would, there'll be a different outcome if it's false, right? So if we need to implement something in your activity diagram, some logic in your activity diagram, we would use if statements as one of the approaches. There's several different ways to make decisions in C# code. But if statements are kind of the primary approach. We'll come back and talk about switch statements and other approaches, right? So let's focus on if statements. The way this works is the diamond shape must have a condition. And in this condition, we're only testing for true or false. A condition must always evaluate to true or false. Remember, we talked about Boolean data types. They have a domain of values of either true or false. True, false is the outcome. So if that condition, maybe some Boolean, something that evaluates to a Boolean value, is true, we might do something. If it's false, we might do something else, right? So here's a silly example. We're coming in the process. Is it cold outside? If it's true, wear a coat. If it's false, don't wear a coat. Continue to move on, right? So if you wear a coat, branch back, and then we flow. So here's how we would express that in C# code. All lowercase if. This cannot be uppercase F. Please remember that. The syntax for this is very critical, right? Boolean expression, something that would evaluate to a true or false. If that condition is true, we would do this. If it's false, we're continuing on. So if it's not true, this part of the code would not run. And this could be a bunch of statements, right? Different things that we're doing in code. So always remember, if the expression is true, then this part of the code would run. So let's look at some different relational operators. We can, to get some Boolean expression to evaluate to either true or false, you can use some of these operators, right, when we're comparing values. So we can say, is value A greater than something? Is it less than something? Is it equal to something? Is it not equal to something? Or greater than or equal to, less than or equal to. The two that I would strongly recommend you pay attention to, because you're probably not used to this. Everybody knows less than or equal to, right? That's the basic thing. Equal to in C# is represented with two equal signs. Remember, we talked about the fact that one single equal to sign means assign a value to something, a variable or some control property, right? So you never want to create a Boolean expression that has one equal to sign. That would not work. You're going to get an error. You would want to have two equal to signs if you're trying to test if something equal to something. And if you want to test if something is not equal to something, then you would use the exclamation sign. In C#, exclamation sign in front of something means not equal to, not something, that type of thing, right? Also pay attention to if you're doing greater than or equal to, because we would speak in natural language, greater than or equal to, the greater than will come before the equal to. Similarly, the less than will come before the equal to. We don't say equal to or greater than. We typically say greater than or equal to, less than or equal to, same flow, right? If you put the greater than sign at the end of this, it would not work. All right, so let's illustrate how we would write a simple if statement example. So you can play around with some of these practice tests. I'm going to launch a console app, and this fires up your lab exercise. So you can follow along to complete the lab. So call this lab 9, and we're going to create a console app. So console app, .NET Framework, lab 9, got what I want. I'll fire this up. In every console app, you could close your eyes and assume you need 2 lines of code. They're always going to be, ideally, console.writing line something, right? So let's start by identifying that. And we would always need to pause the screen after we write it out so we can see what the heck we actually displayed. So I'm just blocking this off so I have a starting point, right? So this is always required. We need to probably show something on the black screen, and we might need to pause the screen to show it, right? All right, so let's say I have a variable, double variable A, and I'm going to assign it a number 50. 5.0 because it's a double. I'm trying to express it in terms of a double data type, and I'm going to create a different way of doing this. I can have var b is equal to, let's say, 7. maybe 7.5 even, right? Notice I'm declaring the variables before I write them out. The logic sequence is very important. I see some green squiggly lines. That's because I've declared variables that I haven't used it. That's perfectly okay. Green is good, not bad. It's just a prompt. Now, if I needed to write an if statement to check if variable a is equal to 5, show something on the screen, and if variable b is something, do something else, then perhaps I would express it like this. If a, as a matter of fact, let me go back to this. In Visual Studio, if I do if and hit tab on the keyboard, the tab key, hit it twice, it would create a very nice structure that looks like this, because C# knows, right, that an if statement must look like this. So it even creates the structure for you in Visual Studio, which means that this is where your condition would go, and then you'd have a bunch of statements in here, right? So I need to test for some condition. So to test for that condition, I can have if A is equal to 5.0, then perhaps console, let me put console.writeLine here, say end, right? So we know where the program ends. But if this condition is met, I want to console.writeLine the value of A is 5, right? So in this case, I've created a variable A, created another variable B. Notice I use the var keyword, but the only way C# knows that B is actually a data type of double is because of the initial value. So remember, anytime you use var, you must initialize the variable. Right? You can't use var without an initial value. Right? So that's just a nice to know. So I'm testing if A is equal to 5.0, which it is, then show this on the screen. Notice we said this part of the code would only run if this condition is true. Okay, so let's give this a shot. If I run this, I get the value of A is 5, and then the other line end shows up, right? So I'm printing on the screen two different things. If this is true, do that, otherwise do that. So that's a simple if statement. An else is part of an if statement if you want to actually do something else. Else means otherwise. So in spoken language, you might say, when the number of A is 5.0, show this. If is similar, another synonym for if is when, right? So if you want to express, if you can think of something and express it in terms of if or when, there's a good chance you need an if statement. If you have in the way you express this in spoken language otherwise as an option, then else would be how you want to express it. You can't use the keyword otherwise in C#, right? We don't know what that means. You must use these keywords. And an if statement optionally can have an else block. If it does, then these are one unit, right? If, open curly, then else, open curly, close curly. Notice you would never have a condition tested in front of an else. You can do that with an else if, but we'll get to that next. But an else never has a condition in front of it. Very critical. Please remember that. All right, so now let's put in console.writeLine, and we would say the value no match found. No match found. Something like that. Okay? So now let's give this a shot. So run this again. The value of A is 5. And notice the line of code that said no match found did not run. Okay, so let me change this to not equal to 5. So if A is not equal to 5, A is 5 at this moment. So by the time I get to line 16, A is already set to 5. But I'm checking if A is not equal to 5, write this line. Otherwise, skip this line and go on to the next block and write this line. So we'll run that. I get no match found, end, right? End is always running, right? Regardless. So that is how the logic would flow. A would be 5. I'm checking if it's not equal to 5, then do this. This is the not. So not equal to 5, this part would not run, this part of the code would run, right? All right, now let's add maybe a little bit of complexity. So let me go back to a state that is maybe a little bit easier to understand. Let's say we're testing for if A is equal to 5, do this, but if else if A is equal to 6, then do something else. So notice I don't have, you have to really pay attention, there's no semicolon in front of this. Lots of students tend to forget that. There's no semicolon, right? This is just a block of code. So you're going to have curly start, curly end. This is not a statement, one statement. This is just a block of code. So block of code, curlies. I would use these curlies if I think I would need potentially more lines. By convention, just use the curlies, open, close curly. There's nothing wrong with having something like this in an if statement. So long as you only have one line to evaluate, then this is fine. You don't need the curlies. But if you anticipate that you might need more than one line of code after the if statement, then add the curlies. So add the curlies by convention. Now notice the difference between the if. The if has a condition, else if, there's a space between the else and the if, right? And then the else if has a condition in front of it, but an else has no condition in front of it. That's very important. An else is the catch-all. If all else fails, do this. If any of these conditions are true, do that. But the sequence of the way this is evaluated is important, right? So pay attention to the sequence of the if statements. That might throw off your results sometimes. So now I want to write, if the value of this is 6, show that the value is 6. And I'm going to test this. Right now it's 5.0. I'm going to change this to 6. Run this. And the value is 6. Right? So you can see the logic actually went down here. And this did not write out, that did not write out, this got printed out, and then that was printed out, right? So you get the idea of how the logic is implemented. Sometimes we can put an if statement inside of an if statement. So we can say, if A is equal to 5.0, do this, perhaps. And then we can have another if, that's a nested if, that is testing if B is equal to 7.5, then do this. I'm going to indent this on the same line. Notice the semicolon is at the end of this statement. I have no semicolon here because this is just testing the condition. If this is this, do that, else I want to do something else. Perhaps I want to say the value of A is 5. Perhaps let's say A is 5, B is 7.5. Right? Otherwise, the value of A is 5. Right? So I have an if statement inside of another if statement. So you can have nested if statements, right? So nested if statements. If I can type well. So let's execute this. First of all, I'm going to change this to 5 because I want this part of the code to actually run, right? So the part of the code that's going to run, the value here is 5, so 5 is equal to 5. I'm able to find that. Then I'm going to test for a second condition. B is equal to 7.5. If that is true, then do this. So if we execute that, so I get A is 5, B is 7.5, which is actually true because A is 5 starting here, B is 7.5. If I change this to 7.4, let's see what happens. I get the value of A is 5, which is the part of the code that is just simply here, right? So I wanted to show you some examples of if statements, nested if statements, else if, else, and that type of thing. So let's go through some of the slides and make sure we've covered all the right concepts. So here are some good examples. We've actually gone through that. You can have statements on the same line. It's totally okay to do something like this. Remember, white space doesn't matter in Visual Studio, so we can have this on the same line, right? But the key here is that semicolon was not in front of this. It's in front of this actual statement where something, an action is taking place. It's really nice to indent things, but white space doesn't matter, right? Notice I didn't have curlies here. That's perfectly okay because I only have one line of code executing. If I have multiple lines, it should be in curlies. And if you don't want to deal with potentially I might have more than one line, just put everything in curlies, right? It makes life a little bit easier, right? If you're expecting multiple lines of code. Now, there is the ability to test if something is true or a different condition is true or a different condition is false, meaning that I can have a neat way of representing what I just printed out here. So instead of doing the nested if, I could implement something like this. So I could say, else, let me implement that here in this section. So I could say if A is equal to 6.0 and, so the double ampersand, don't worry too much about these two. The two pipes means or, we're testing for or, multiple conditions, and the two ampersand signs means a conditional and. So we can test if A is equal to 6.0 and B is equal to, let's say 7.5, but I need to fix this, then do this. Perhaps we would say A is a match, A and B are a match, right? So if A is equal to 6.0 and B is equal to 7.5, A and B is a match. Perhaps I can have this piece of the code run to test this. So I'm going to change this to 7.5, right? Because I want that piece of the code to execute it true, and then I'm going to run this. So A and B are a match, right? You can see that end up. So 6.0 is true and 7.5 is also true. If both of these conditions are true, then this would run. You could play around with this console.writeline to figure out which conditions would evaluate to true. So if you're testing if something is true and something else is false, right? What would be the output? If you're testing if something is false and the other condition is false, what would be the output? When you're testing if something is true and something else is true, what would be the output? I want you to play around with that and get the results. Will help you build a sound logic foundation. You could test if something is true or something is false, right? So if I changed this to pipes on the keyboard, perhaps this would not evaluate to what I'm expecting it to. So A and B are a match. So if A is equal to 6.0 or B is 7.5, so if any of these conditions are true, this piece of the code was actually running, right? Because either one of them was true. So if I change this to 7.4 and run this, logically, A and B are a match. That's just what I'm showing here, right? They're not really a match because it's a 7.4. But if I were to change this to 6.1 and run this, now 6.1 is not going to match up with A, and 7.4 is not going to match up to B, right? So let's run that, and we get no match found. So it's running as expected. So I just wanted to illustrate the ands and the ors, so you get some exposure to that. Play around with this and see if you can figure out what the output of this code segment is. Very good example for midterm exam prep. String.empty is used to assign an empty string to a variable. So if you want to create a variable and initialize it to an empty blank, you can use this approach, right? So be aware of it. If else, we talked about it. We looked at a more complicated example I just showed you. Play around with the practice exercise. Try to see if you can rewrite this code using an if-else statement. Follow the logic, play around with it. If-else, just a good pseudo code and flowchart practice with it. And I've showed you something more equivalent to that. And please pay attention to the fact that the sequence in which we test the code with if-else if is very critical. So here's an example. If I were building final grades for the class in Excel, I would be doing something much like this. So if your score is between blah, 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 and blah, 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 give the person an A or a B or a C, things like that. I'll recommend you play around with this practice exercise and see what the output looks like and change the different values and see what you end up getting, right? Nested ifs, we talked about those. Here's an example of a flowchart. Here's an example of implementing a nested if. And then that's it. That's all we needed to cover. Working with strings is not something we're going to cover in the midterm exam, so we'll come back at the end of the midterm break and we'll work with a more elaborate lab exercise where we play with strings and web pages. Right, so if you've completed these steps, that is lab 9, and you can simply zip up your project, upload it to D2L for lab 9, and you should be done. Feel free to reach out if you have any questions. Have a great weekend. Take care.